Okay, give you a minute, soak it in. I will answer anything that's up there. What do you mean by this? And then we're going right to the review. All right. Usually I'm like, all right, you guys do the review. Answers are here. Not today. All right. Not today, just because we have not had a test yet in this unit. And you'll see something, a little review there at the end I threw in there. And I'll tell you why I threw it in when everyone's ready to go. Yes, Mason. Well, remember, the apothem is the same as the height in one of those triangles that you create. So whether you know it's the apothem or the height doesn't matter, but you still should be able to find it if it's a hexagon, triangle, or square, and I ask you to find the area of it. Okay? No formulas will, well, actually, I shouldn't say that. I am going to give you a reference sheet tomorrow. Here's what's on the reference sheet. Triangle, parallelogram, and circle. That's what's on your formula sheet. So if you can't remember the areas of those, trapezoid is not on there. Either is kite or rhombus. Triangle, parallelogram, and circle areas are the only ones that are on here. Okay, anything you want to ask right now about what's on there? First thing, why did I put 5 centimeter by completing the square back on there, even though it was last unit? Basically the only reason being I told you it was going to be on there on quiz 3, and some of you took advantage of that and knew how to complete the square. Others, I hate to put it this way, but basically just laughed in my face and didn't really care about it. I didn't want to figure out how to complete the square or review that, so I put it back on there. All right, we'll figure it out sooner or later. So that's back on there tomorrow. Ask away. Anything here before we get going with the review problems? Anything you want to ask? Now's the time, because I'm not going to go back. Remy, go ahead. Absolutely, yep. First of all, let's go over, because I don't have any review problems for it. Real quickly, what is the formula for population density? There's a formula for it. Population, whatever the population is over the land area. Yep, area. Yep. So that's how I find it. Population density equals population over the land area. Okay, I'm going to have to make this up here, so I don't know how well this will work numbers-wise, but we'll try it out. Jack, you want to just pick a city? Okay. New York City, here you go, has a population density, and I'm totally making this up, has a population density equal to 2,102 people per square mile. The population of New York City is equal to, I don't know, what do you think? 2,135,000? No clue. How big is New York City? How many square miles is New York City? So find the size of New York City. So what am I doing here? I gave you the density. I gave you the population. Find the size of the city. Billy? Okay, so hold on. You're basically using the formula right now, which says population density, in our case, 2,102 is equal to population over the size, x. Yep. How do I solve this? How do I solve this now? Cross multiply both sides by x. So I get 2,102x equals 2,135,000. Divide both sides by 2,102. I'll go nearest tenth for me, just so we don't get crazy. So New York City, 1,015.7 square miles. That's very similar to what I'll give you tomorrow. But it might be, I might give you the information for a couple states and say rank the states from biggest to smallest as far as the area goes. Okay? I don't mind telling you what's there if you want to take advantage of it. Anything else on here before we go? Anthony, what's up? Sure can. You got any of the ones I gave you yesterday? So I don't have to look it up. No, the one, like the example ones that I threw at you yesterday. Do you have those written down, or did you throw those away? No. Like, remember you came after school yesterday. I gave you a couple completing the square ones. Did you write those down that you can just give me right now? Can you give me it? What was the equation? Just so I don't have to go back and look up a brand new one. Okay, there you go. There's a circle equation. What's the center and the radius? Thank you, Emma. Okay, first step tomorrow. What are you thinking? First step. Emma? Well, first group the x's and the y's if they're not already, and also make sure the single number is over to the other side. We're all good there. All right. If it's -6, add it over to the other side. Get it over to the other side. So I got x squared, group them the x's, -6x, plus y squared, bless you, plus 2y equal to 6. Group them all together. Nice job. Now we start completing the square. First for the x's, how's this process go, Anthony? Half of -6. Everyone ready? Because this is where people get lost. So everyone take half of -6 right now, and then do what with it? Square it. Everyone have that number in your head now. Take half of -6 and square it. What number do you get? +9. Yes? Okay, so ready? X squared minus 6x plus 9. This number should always be plus something. When you square any number, it's always positive. Now do it for the y's. Y squared plus 2y. Everyone in their head right now. Divide 2 by 2 and square it. What's that new number now? 1. So again, it's always plus 1. And then here's where I lose, kids. Either you don't do anything to the right side. Again, what did you just add to the left? 10. So that's what you're going to add over here. Hey, this is what happened on quiz 3. Some of you guys tried to move it over by subtracting. No. Keep it balanced. If you added 10 here, you add 10 here. You don't subtract 10. You do the same thing on the left as on the right. So I'm going to add 10 as well. Done. Okay, next up. Now we got a factor. instead of factoring, I try to give you guys a shortcut. What was half your b value for the x's? So it's going to be x minus 3. What was half your b value for the y's? 1. So y plus 1 squared. And then what do I get on the right side now? Guys, if you get a negative number over here tomorrow, something is wrong. If you don't get a perfect square, something is wrong. All right, I'm not going to fool around and give you something that's not a perfect square tomorrow. Now, answer the question, what's the center? If I have negative 3 and positive 1 in here, I change the sign. So the center is going to be positive 3, negative 1. And this is not 16, it's not the radius length. It's the radius length squared. So what number did I square to get to 16? 4. That's the radius length. All good there. And hey, if you want to come in today, I got plenty of these. All right, not as many as the big circle questions, but I got plenty of these. Or if you want to shoot me an email, I can definitely hook you up with some tonight. All right, these completing the squares, I got a lot. Anything else from the review we want to go over before I get into the actual questions? All right, let's do it. 5, number 5. Read through it. Go ahead, read through it. I'll ask someone, what's our plan of action here? Okay, this is what we covered yesterday. Similarity is 4 to 7. Area of one of them is 128. What's the area of the larger one? Can I please hear the ratio you would set up for this? 25. I want to take this one. First of all, what's the ratio of the sides? 4 over 7. The 128 is that, which pentagon does that belong to?
The smaller.
So it should go across from the 4 because that's a smaller number in the ratio.
128.
Yep. And then X for the larger one, but this is incorrect. That's not correct. The side ratio and the area ratio are never equal. Can you adjust it for us, Mason?
Yes, you want to square the entire right side.
Yeah. Right side? Right side?
No.
That's, I don't want to square the areas.
Yeah, left side.
Left side, I want to square the similarity ratio. Yep. Okay. And then you guys can go get after it now. So 16 over 49 equals 128 over X. So you end up with, and I'm not going to ask anybody this, 392, and I warned everyone at the beginning of the unit what's happening tomorrow. Units, no units, half a point every time, all right? No units, half a point every time. If it doesn't have units, I won't expect it, all right? But if it does, half a point every time here. Billy. Sure. I won't be impressed, but sure, go ahead. All right. 6. How are we going to find that shaded region? Oh boy, this one's a little different, huh? How are we going to do this? Huh. Shaded, not the unshaded, the shaded region. Ooh. Because usually I find the area of the whole thing and minus the unshaded. I have no idea what the whole thing is. I don't know the area formula for that. Everybody got one drops of knowledge here? How can I, or just give me a plan to find the area of the shaded region? 27, got anything? Okay, so you want me to, okay, I got you here. So, whoop, let me do white. So you want me to do, so if we're going to find the area of the whole thing here, I don't know what to call the whole thing, so I'm just going to call it whole. You want me to do half circle, right? Half pi r squared plus the, looks like a square at the bottom. Okay, everyone see that? The whole thing can be made into a half circle and a square. Okay, what's the radius of that half circle then? 5, radius of that half circle. 5, half of 10, good. So I'm going to go 1/2 pi times 5 squared plus, what's the area of the square? Come on. 21, area of that square? 100, 10 times 10, nice. So whatever decimal you get from that, don't round. And then what about the area of the triangle now? How do you find the area of the triangle? Oh boy, 20, you're up. Area of the triangle? Oh, 1 job. How about 1? Matt, how'd you find the area of the triangle? 1/2 base times 10, height is 10. So the area of that triangle, 50. And I always ask this because I've heard different ones. What am I doing with the 2 here? What am I doing with the whole area and the triangle to find the shaded region? 2? I subtract the 2, yep. So you guys can do that on your own, and then I'll ask you what you get in a second. And there are no directions, so we're going to write out the full calculator to display, but just give me a couple numbers in that for me.
So what I did is I did the square. I did the whole square.
And you just added them.
Yeah, and then I subtracted the triangle.
Yep. You could do the half circle plus the shaded triangle. That's fine too. Yep. Still get there the same way. Either way, here we go. 16. What do we end up with? Just give me a couple numbers so I know we're on the right track.
The shaded region is 89 point round anywhere.
Just keep going with a couple decimals so I know you're good.
2699.
Okay, you're good. Thank you. 0817 and then units, meters squared. Anything else? Okay, I think we're going on to number 10 now. Find the area of that shaded region. What do we call that? We've got a name for that, this unit, this shaded region here. That's the center. What do we call that shaded region in the circle? We have a name for it. 28, remember the name? No, you don't because you're not here. 5, remember that name there, Fiona? The blank of a circle. Looks like a piece of pizza or a piece of pie. Keep searching, probably day 3. We spent a day on it. There we go. Sector, that's a sector. And we have a formula for the area of a sector. Anybody want to remind me of the formula here? Yes, you do. 14, area formula for a sector. Degrees. Well, this is in degrees, so I'll take the degrees one. Yep. Got it. Also, I don't know if you saw it already, but on the beginning of your packet, where question 1 is, I gave you guys all the formulas you need to know. Okay, at the beginning, yeah.
Just a quick question about the equation. What would it be if it wasn't in degrees?
What do you mean if it wasn't, if it would be in radians?
Yeah.
It would be the other formula then.
Yeah.
Or you can convert it, what's that? 1/2 r squared theta. I'm going to tell you right now, don't worry about it. Don't confuse yourself. Tomorrow, if there's a question on a sector, it's going to be in degrees. So just remember the degrees formula. Regents time, we'll remember both. All right, so here we go. A little help from 15, filling it in. What's the measure of the arc? 36 over 360 times pi. How about the radius, Henrik? 11 squared. I'll ask you guys, leave it in terms of pi for me right now. Leave it in terms of pi. So go ahead, do your number crunching. Leave the pi in your answer, though. Leave the pi in your answer. When you're ready, leave it in terms of pi for me. 19, what do you have in terms of pi? Yep. Or you can have, if anybody had the fraction, 121 over 10 pi, that's fine. 12.1, any units? Nope, so I wouldn't expect any tomorrow, unless Billy wants to show off and put his u squared in there. All right, that's fine too. Yes, Nika, go ahead.
I thought you said you combined like the 1/10 and 121 into pi.
Say that again?
I thought you said combined.
Well, it's all multiplication.
Oh, okay.
So I can do 36 over 360 times 121.
Oh, okay. So that's
Yep. Yeah, I can do it's all multiplication. Now, hey, ready? If I put an addition symbol, you're correct.
okay.
I can't combine those because the other one doesn't have a pi in it. Yep, if I added or subtracted. All right, what's up next? Oh, look at this beaut right here, number 9. Little logo. What's the area of the shaded region in terms of pi? A square and 4 quarter circles. What's the area in terms of pi? So I'll start with the square first, because it's going to be square minus your circles. Square minus circle. So let's start with the circle. How do you find the area of the circle? 7, great job. 27, how about that? How do you find the area of that square? Which would be what in this case? Okay, so 6 times 6, got it. Minus, how many quarter circles are there? 4 makes a full circle. So I'm going to use pi r squared here. Just need a little help with the radius length of one of the circles. 8, radius length. What am I doing? Act like you've been there. 28, act like you've been there. 16, radius length of the circle. 3, nice job. Perfect lead into your question here, Nika. You just asked. 36 minus 9 pi. Can you subtract those? No. One has a pi, one does not. This is your answer in terms of pi, except what about them? Square inches. You cannot subtract those. Not even close to done yet. Any questions on the old shaded region here? All right. How about go back to the beginning, number 3. Let's find the area of this kite. First need the area formula, just get us started. 19, area formula for a kite. What was that? Okay, that's what I thought. Thank you. One diagonal already given to you. We just need to find the other one. And if I'm going to go nuts, the diagonals are not the same length. Whether it be a kite or a rhombus tomorrow, diagonals are not the same length. We're all good there. Okay, what you plug in for D1 and D2 should never be the same for a kite and a rhombus. All right, everyone, draw in your old diagonal here for a kite. Since it's a kite, anybody, I know this has been a while, property, they do not bisect each other. All right, the longer one, there's something else there. Anthony. Okay, there's one start. They're perpendicular. Longer one bisects the shorter one. So this 24 is being cut up into 12 and 12. Everyone all right? But the longer one doesn't get bisected. All right? So everyone see, we're going to have to do Pythagorean theorem twice. All right? One for this top right triangle and one for this bottom right triangle. All right? So somebody set up Pythag for one of the two. I don't care. 20, not here. Or do we have 20 here? Good. 14. One Pythag. That's all I need. 12 squared plus b squared equals 13 squared. Got it? That should be a nice number, hopefully. So one part of the diagonal should have been 5. Yep. One part of the diagonal should have been 5. Oh, I remember this one. We're just going to go with it. The numbers don't come out to be correct, but we're just going with it. I remember this one. And then can you set up Pythag for the second one? 21? Yep. We're just going with it. And that length comes out to be 9. So the other diagonal, and I know it's backwards, we're just going to go with it here. The other diagonal, 14. So we end up with 168, no units, so I'm not going to put any on. If it's a rhombus tomorrow, diagonals are perpendicular and they do bisect each other. All right. If for some reason I have a rhombus. Yes, Thomas. No? Well, what's in the directions already? So I know you're finding area. Right? Good. If you want to put units squared, I'm okay with that. All right, but if there's no units on there, I wouldn't expect anything on there. All right. Can you guys go to, my pages may not correspond, page 25. So not only do you have these 11 problems in the packet and the answers are on the following pages, all right, everyone see that? Answers are on the following pages with work. You also have a bunch of textbook questions to try out as well, which are also in the back of your packet, those answers. Okay, there it is. All right, what you do from here on until tomorrow is up to you. I'll be here after school if you want to review. If you want to toss me an email about do you have any extra of these problems, I'll do my best. I don't have problems for everything, but most things I do, so that's up to you. All right, so here we go. Whatever you want to work on, you want to grab a textbook and try some of those, go right ahead.